Okay, question number 13. Which of the following statements best describes parity checking? Yeah. So when you take a look at the choices here, the very first one is telling you, okay, this parity checking is best suited for detecting single bit errors in transmitted codes. That is true, okay? Because we only detect the single bit error for this simple parity method because it isn't capable of detecting the double bit errors. Yeah. When you take a look at it, let's say I have a data group 1111 and I want to check if my transmitted data correctly get to the receiver, then I'm going to add 1, all right, to my data group. So when you count the ones, you see 1, 2, 3, 4. That's your original one is even, and when I add my parity, I have odd ones. Okay, so if I had an error in my code, instead of 1111, I had an error 0. All right, only a single bit error. So I got 0111. So when I do the parity checking, instead of giving me the odd, all right, total ones, it's giving me the even total ones. See, 1, 2, 3, 4. So therefore I know there is an error, right? And that error is happening on a single bit, only one. Because if you have two, right, double bit errors, you can do parity. Because in this case, you will be getting odd total ones, yeah. Because I have 1, 2, 3, 3 odds, yeah. So the counting will be showing the overall odd for this data group, and that would be the same as your correct, right, data transmission, because the correct data transmission overall is odd, right, total number of ones. So 1, 2, 3, 4, 5. This one 1, 2, 3. So that's one reason why you can't be able to detect double bit errors with parity checking method. Yeah, it's only good for simple array single bit data checking. For complex data, we use redundancy checks, so we call it the cyclic redundancy checks. We also use the Hamming code or Reed-Solomon codes, but you will learn these things later. Right now, we're going to continue. So this is wrong, and C is wrong because it's not the best choice, because it's saying like parity checking is capable of detecting, of course it is, and correcting errors in transmitted codes. That's kind of very vague, right? And this is more it is a better description than general description like that. So therefore we choose A over C. Yeah? And parity checking for D, it said it is not suitable for detecting single bit errors in transmitted codes. That's totally wrong. Okay, that is false, because you definitely can be able to do. This is a negative, right? Completely opposite of the answer A, because you can be able to detect the single bit errors in transmitted codes with this method. Okay, so the answer for question number 13 is A.